Okay, solve the inequality. The absolute value of x minus 1 over x minus 3 is less than or equals to 2. Alright, so to solve this equation, this inequality first, okay, from the inequality, so we must separate first. Alright, so to separate, first we copy, okay, the same expression, we just without the modular sign. So we have at the left hand side we have x minus 1 over x minus 3 less than or equals to 2. And then, okay, after copy, at the right hand side, okay, we change the sign, okay, which is we take the fraction which is x minus 1 over x minus 3, and then, okay, less than, it become greater and equal, okay, and then from 2 become negative 2. Okay, so now we must solve these two rational inequality separately. Right, so we solve for this part first. Okay, so we must change the right hand side, which is equals to 0. Okay, then don't forget to put n here, because less than will be n. Okay, so at the left hand side here, okay, so first we must change the right hand side is equals to 0. So we bring the negative 2 to the left. Okay, it's become x minus 1 over x minus 3 minus 2 is less than 0. And then we need to combine these two term into one fraction. Okay, so we cross multiply. So we have x minus 1 minus 2 times x minus 3. And then we can simplify the numerator. So if we simplify, we get, so we multiply first negative 2 inside the bracket. It becomes negative 2x plus 6. And then x minus 2x is equals to negative x. And negative 1 plus 6 is 5. So at the numerator is negative x plus 5, or we can rearrange, this is 5 minus x. So we have 5 minus x over x minus 3 less than equals to 0. Alright, so we can do, okay, we can solve this using the table of signs. So first we need to find the critical value. Alright, so for the numerator, okay, numerator which is x minus 5 is equals to 0, okay, because we have a equal sign here, so we let equals to 0. So we have x equals to 5 for the numerator. And for denominator, which is x minus 3, this one we is not equals to 0, okay, because if equals to 0 at the denominator, it will be undefined. So we must put here not equals to 0. Okay, and then we simplify, we get x is not equals to 3. So we have two value here, which is 5 and 3. Right, so to create the table, okay, first we rearrange, okay, from in ascending order from the smallest to greatest, which is the smallest value is 3, and then 5. And we also put, okay, at the far right side is infinity, and at the left side is negative infinity. And then we create the table. Alright, so for the first row, we write down the interval. Okay, so in between negative infinity to 3, this is from negative infinity to 3. And here we use a round bracket because x is not equals to 3, so we cannot include 3 into our interval. So we use the round bracket. Okay, so in between 3 and 5, okay, we have 3, 5. So 3 is not included, but 5. Okay, we use square bracket because we have the equal sign at the inequality, so we must include 5 into our interval. And then the next interval is between 5 to infinity, so 5 is included, okay, to the infinity. Alright, and then we must find, or we must choose the suitable test value. So we just pick, okay, some number which is in the interval. So in between negative infinity to 3, let's say we choose 2. And then between 3 and 5, we can choose 4. And then greater than 5, we can choose, let's say, 6. And then what we do, we substitute all these test value into the fraction, which is negative, which is 5 minus x over x minus 3. And we just want to know the sign of when we substitute this value. So if we substitute 2 into this fraction, we get the value is negative. And if we substitute 4, we get the value is positive. and if we substitute 6 we get negative. Alright, so for this part we want, okay, the inequality which is less than 0. So less than 0 is negative, so we want the negative part. So the negative is this interval, so we just copy back the interval which is from negative infinity to 3 or from 5 to infinity. Alright, so this is the solution for the left side of the inequality. Right, so we move to the next inequality, which is x minus 1 over x minus 3 greater than equals to negative 2. Right, so the same is applied here. So we need to change the right hand side equals to 0. So we bring the negative 2 to the left hand side. So it becomes x minus 1 over x minus 3 plus 2 is greater than equals to 0. And then we combine this, become one fraction. So we cross multiply with 3 minus x, okay, and then we simplify. So if we simplify this, we get x plus 2x is equals to 3x, and then negative 1 minus 6 is negative 7. Okay, so this is the inequality at the right hand side. 3x minus 7 over x minus 3 is greater than equals to 0. Right, so when we have this inequality, so now we can find the critical value. Right, so for numerator, which is 3 minus 7, we equate equals to 0, so we have x equals to 7 over 3. And for the denominator, which is x minus 3, okay, is not equals to 0, and then so x is not equals to 3. And then we create the table. So we rearrange so that in ascending order. So the smallest value is 7 over 3, which is around 2.3. Okay, the smallest. And then 3. And far right we put infinity. And at the left side we put negative infinity. And then we create the table. Right, so the first row is for the interval. Okay, the first interval is from negative infinity to 7 over 3, and 7 over 3 is at the numerator. Okay, since we have a equal sign here, so we must include 7 over 3. And then between 7 over 3 to 3, okay, 3 is, okay, round bracket, because 3 is not in the interval. Okay, and 7 over 3 is in the interval, so we use the square bracket here. And then from 3 to infinity, okay, is all is in round bracket. Okay, so next is the test value. So we choose, okay, the value which is in the interval. So less than 7 over 3, let's say we can choose a 0. Okay, between 7 over 3 and 3, okay, we can choose maybe 2.5. Okay, because 7 over 3 is around 2.3. Okay, so we can choose 2.5. And then greater than 3, we can choose, let's say, 4. Right, so we substitute all this test value into the fraction, which is 3x minus 7 over x minus 3, and we just want to see what is the sign. Okay, right, so if we substitute 0 here, we get positive, and if we substitute 2.5, we get negative value, and if we substitute 4, we get a positive value. Okay, so for this question, we want the inequality is greater and equals to 0, which is a positive value. Alright, so the interval is the positive result. So which is the interval is from negative infinity to 7 over 3, or from 3 to infinity. Alright, so now we have these two solutions, okay, for left and right side. So we must combine these two solutions. Okay, to combine, since this is n, so we must combine with the intersection operation. Okay, so to do the intersection, so we must use the number line. Right, so the first we draw the number line for the inequality at the left side, or before that we just put the number which is involved here, which is the smallest is 7 over 3, and then we have 3, and the greatest is 5. Right, so we draw the first number line for the first interval. So from negative infinity to 3, okay, so from or this is less than 3, Okay, so the arrow at the left side, and then greater than 5. So from 5, okay, so 5 is included, so we put a fill inside the circle, and then the arrow is pointing to the right. Okay, next interval is from negative infinity to 7 over 3, or this is less than 7 over 3. So 7 over 3 is included, and then the arrow pointing to the right, to the left, and then greater than 3. Okay, from 3, okay, we just put a circle without a fill because 3 is not included, and then the arrow is pointing to the right. Alright, so for intersection, we must take the interval which is, okay, the line um, is intersecting each other. So okay, the area which is the line is intersect is less than 7 over 3 and greater than 5. So we take that interval. So the first one is from negative infinity to 7 over 3, or from 5 to infinity. So this is the solution for the inequality.